Okay, this is number 9 on section 10.7. I labeled the information in the picture. Arc AD is 60, angle B is 115, and BC is parallel to EF. So I'll highlight those two lines in red so that you can see the parallel lines. Okay, so this is what I got, and I'm trying to determine angle ADC. So first things first, angle ADC, based off the theorem we just learned, angle ADC has to be 65. The reason is opposite angles in an inscribed quadrilateral are supplementary, so therefore I subtract 115 from 180 and get 65. So that one, first question, pretty easy. Part B, angle CDF is the next question. Well, that's this angle here. And this one requires a little bit more thinking as far as what you want to do there. Angle CDF is a little bit harder to find. If you're thinking that this is a trapezoid, stop thinking that. There's nothing in this picture that lets you say this shape here is a trapezoid, okay? So let's figure out what angle CDF is. The only other information that I know is I could figure out how big that angle is. This is a tangent chord relationship, okay? Tangent is like segment ED and the chord segment AD. And I know that the angle is half the arc, very similar to when you have an inscribed angle. We just don't see this situation very often. So therefore, angle ADE is 30 degrees. And I know that 30 plus 65 plus this angle are going to make 180. So I subtract 65 and 30 from 180, and I get my angle. 65 and 30 make 95. So my angle is going to be 85. But just to make sure, I'll check it in my calculator. So then I know that this is 85. Okay, so angle CDF, part B, equals 85 degrees. Part C, angle C now, because these lines are parallel, I know that the Z shape is created, which means that this is alternate interior to angle CDF. So angle C and angle CDF are congruent by alternate interior, which is why angle C is also 85. And then lastly, angle A, the only angle I haven't found, and much like problem or question A, these angles here have to be supplementary. So if I know that angle C is 85, I know that angle A is its supplement. So you just subtract it from 180 and get angle A is 95. So if there were any part of that you didn't understand, slow it down, look back at your notes. But that was a tricky question that I wanted to make sure that I went over. So this was 10.7, number 9. Moving along, we'll go to 10.7, number 16. This one has typically been confusing for students simply because of where the radius is drawn. Students think that they have to keep the radius there, that JO or OJ, the radius being 6, needs to be there. Well, I'm going to say right now that's the one thing that you can know is wrong. You don't have to keep it there. You can put it wherever you want. And in fact, I'd rather put it I'd rather put the radius to one of the vertices, and that's going to actually help me find what I'm looking for. So arc HG is 120. If I draw in this diagonal, I know you're like, well, why would you draw that in? Well, it's because I know if I draw that in, I can tell you that this angle is 60 because it's half of the arc. And I also know that OJ being 6 tells me that this whole diameter is 12 because the radius is 6, so each piece here is 6 and 6. Okay, so if there's any question as to why this diameter is 12, stop this and think about it and try to figure out why, but it's because the radius is 6. Hey, it scared me. You're gonna be on the web now, so you know. So now there's a 30, it's a 30, 60, 90. And if you're watching this, somebody just came into the room and freaked me out. The hypotenuse is 12, short leg would be 6, and then HG would be 6 root 3. So the perimeter, it's a rectangle, it's a parallelogram, but I know a parallelogram inside a circle, inscribed in the circle, is a rectangle. So that makes the perimeter here 6 plus 6 plus 6 root 3 plus 6 root 3. So the total perimeter is going to be 12 plus 12 root 3. That's the answers to number 9 and 16 from 10.7.